This conference will now be recorded.
Right. Hello everyone, thanks for joining tonight. I'm Craig Havard, I'm the Senior Gauge Engineer, well, as of today I'm the Senior Gauge Engineer for Wales and Western Region. Just a bit about me, I've been on the railway for about 13 years now. Worked in various different places like maintenance, renewals, and back in asset management again. And tonight's presentation is a bit around what I've been doing for the last 2 years with NetRail actually having a problem with gauging data and how we sort of resolved it using RILA. So I'll move on to it. Right, so the aim which I sort of looked at today was sort of when I started about 2 years ago, and even when I started maintenance surveying probably about 10 to 12 years ago, we were using various traditional methods, which I'll go over today, and then recently, well, over the last 10 years, we've noticed that the gauging surveying has been getting a bit more modern and more laser-based. From that, I'll go into a bit of RILA and what we've sort of procured from them to help with our gauging sort of surveys, and then a bit about what vehicle dynamics affect the gauging, and then how we sort of put everything together and come up with a clearance calculation. From that, then there's obviously things that go wrong, as you can see from the picture. There's I think there's a tamper at Newcastle which managed to chip away the front of the core bridges, and then sort of the second part of the RILA sort of stuff is looking at how we're using the data going forward and the future for Wales and Western, because it's not just Wales that have this data, now Western are in the process. So traditional survey methods, as probably everyone's aware, the pole and tape. So it's just using pretty much a tape held against a structure or attached to a pole or a stick, and we pretty much triangulate to get our X and Y heights and offsets. From this, then we can build up a 2D image of a structure. So, as we usually would, a tape, the track gauge as well to get your count. Back where we used to look at things before was pretty much the Havard handles and string to get over curvature. And a stick, if needed, for our sort of upper sector surveys. And these are still acceptable to this day with a plus or minus 50 mil tolerance, which is probably a bit better than what actually should be. This is the form that used to be used. This is our TEP form in NetRail, our TEP 3049, I think it was, which we used to use to sort of position our readings then for each structure. And I was quite surprised this only got withdrawn in 2008. So this is potentially still being used up until 2008, which is a bit of a shock, really. There. And this is the type of profile we get. So throughout this presentation, you see the same similar profile. And I thought, since this is South West Wales, I've used an overbridge which takes you down to Kiln Park in Tenby. So nice area. So this is the type of profile we get. You can see it's very sort of square, and a lot of the sort of points are sort of merged together to sort of perform a straight line between each point. As we go through the presentation and the newer survey sort of methods, you'll be able to see that these points are actually a lot more accurate these days. And on top of that, these lines are going to be 50 mil thick because of the actual tolerance on the survey equipment. So I'm not going to touch too much on platforms, but being a traditional survey method, even this is more of a newer bit of kit. When I started, it was pretty much a square made out of wood with a measuring tape stuck to it. But yeah, it was in the gauge again. We looked for heights and offsets to the platform edge, and that's what we used in the advanced gauge then to get the X and Y's. Still using cant stick in places to get our cant, and the same again for radiuses and curvature information. We're looking at Havard method. And the main thing with the platform edge, we're looking at a theoretical point. So as you can see there in that core bridge being a round core bridge, we're looking at putting a square in it to find attribute 13, as is known in CLIO terms then for our sort of attributes. We're trying to find that theoretical point. What we find with the newer methods is that we actually get in the curve surveyed. So the attribute 13 in theory becomes sort of obsolete, but it's still needed for stepping distances. So as we move forward onto laser-based survey methods, so we're looking at laser sweep and route scan is the sort of general feel around maintenance on Western Wales. And this is pretty much using a single point laser from a fixed point, and the same again, it generates your X and Y to your structure. Again, it's processed in 2D. The only thing with this is that the longitudinal position, just like pole and tape, is determined by the user. So we're not really getting much repeatability with these surveys because the user could put it however far further forward. Even if you're looking at a platform and you're going across a different coper, you could be 10, 20 mil and get a completely different reading. Same again, track radiuses and adjacent track information are still required manually. But that's a laser sweep for everyone who might not have seen them before. That's the sort of general kit which we have in maintenance in Wales and in Western, and there we are, the root scan as well. So what we get with this is that the laser itself is at a fixed point above the sort of running edge, and then from there, then it will do a continuous sweep of regular interval readings, and that will give us a bit more of a detailed sort of view of the structure, and then same again with the cant. This again a bit closer, and this now will give us a 14 mil accuracy, so it's much better than the pole and tape. So we start going to Trainbone. So the Trainbone laser system, which runs everywhere now, is a structure gauging train. So this operates within our ultrasonic testing units, 2 and 4 rigs. We do have potentially the issues there when it's rerouted or possibly reprioritized to other routes, regions, areas, wherever it may be. And yeah, the same again, it captures X and Y offsets, but this time it does a continuous laser scan in the 360. Very similar to other methods which can be done manually, but this one has a added sort of nuance that sort of this does composite profiles. So it will do a continuous sweep over a full structure, but it will do it in 5 meter sections, and each of them 5 meter sections will pick up the worst case scenario. The only thing with this is that it sort of does tend to pick up a lot of vegetation, as the vegetation will potentially be the worst point within that 5 meters, and then we do end up getting profiles like this. So as you can see there, the points that are sort of close to the track would be attributed as vegetation, so it's quite difficult then to sort of find where the real structure should be. But the structure gauging train runs fairly frequently. We have the issues then of processing the data. As this runs everywhere and is processed to one team in Milton Keynes, we do get issues with backlogs of processing. But this sort of brings us a bit better, a bit closer to where we should be in terms of age of data, and then the same again with in terms of accuracy of data. So we had a problem. When I started 2 years ago, there was a problem. So the data held in the National Gauging Database is too old, and the accuracy of the data is inadequate in many instances. When we're looking at too old, at the minute we're looking at compliance to standards, so what's out of date, what's in date. And then same again, it's the minimum and maximum sort of frequencies. So we pretty much need to resurvey the majority of our infrastructure in Wales over the next 6 to 12 months, and at the same time we need to use more accurate data to make more informed decisions based on risk. Now, if we went to the maintenance guys to sort of look at this would take months, years to do. The structure gauging train, yeah, so too long, too difficult. The structure gauging train could capture the data, but natural processing would mean prioritization again. So we may have all the data sat there, it just may take months and months and months for us to process this data. So I sat down with our track ram at the time, and we decided what can we do. So pretty much our Wales route solution to this was bringing RILA in. Now RILA, I know a lot of guys on the call now, is a bit of kit that's owned and operated by Fugo, and within Fugo there's another sort of Fugo rail data section who sort of hold all the sort of rights to this. So they're the guys who own RILA and will operate it and give the data over to us. So what is RILA? So RILA, suite of train mounted sensors, is pretty much a box that fits on the front of a train or back of a train, and in that box we'll have various sensors, cameras, laser sweeps, and as you can see there's sort of the chimney spout of it and the GPS antenna. This then we can attach to the back of the service train and run wherever we need to. So Fugo provide the equipment, output there's additional layers imposed, including track data, gauging, asset, other measurements, but primarily all of it comes from a point cloud data set. This point cloud data set is all collected at line speed on the back of the service train. The only type of access we would require is to get it on and off a train. Apart from that, it's all done under usual running services. So these are the sort of point cloud outputs. So these aren't pictures, these are actually dots made into, well, 3D dots everywhere. Millions of dots that pretty much paint a picture of what's there today. So on Wales route, when I sat down with the track ram and we decided what we're going to do, that was what we covered. Covered about 97% of all structures on Wales. We didn't do certain freight lines because it didn't seem very sustainable at the time to carry on doing these surveys. So we covered all the main pasture lines plus a few others. So at the time, this was one of Fugro Network Wales project, the largest ones they've done. Since then, there has been other areas which have done the same. We've done this back in January, February time, 2019. So yeah, 97% of all Wales is covered. Funded by a track ram under a fixed price contract. We have full collaboration between the sponsors and the new operator, which really did help with us because the operational part of this is quite difficult. We tried doing it in a really short time scale and getting everything all back and updated for NGD. So yeah, as it says there, we had about 15,000 structures. We captured everything within 6 weeks. There was a bit of data processing afterwards, but if we looked at doing this through maintenance, it would have taken, as I said, about 3 years with no rests, no breaks, no nothing. So we got a massive efficiency there, keeping guys off site, and at the same time, there's a massive program efficiency anyway. So a bit more what is RILA. So in this video, it's going to show the Fugro guys, the operators, attaching Fugro to the RILA to a train. I think there has been talks that this can be done, sort of changing ends within 4 minutes if you had enough dwell time. So it's just attached to a coupler onto the train. Then there's a 2-man lift and to get the actual RILA box onto the train. All the sort of recording and storage of data is all done through the cab, and it's all wireless then to the guys actually sat operating it through the back cab. There are operational constraints to this as well, but your dwell times and not holding up a train. There's also requirements to have your designated person there and sort of make sure that sort of everything is all done as per the rule book. So the thing to remember is everything's going to be in the back of the train, not to interfere with the driver. So when we do want to go and do 2 runs on a certain route, we look at put it on the back, going in one direction, then when we stop the other end, we make sure we've got enough dwell time to get the kit off and swap ends and back on. As soon as the antenna is up and everything's out to the 4 foot, we can still carry on then and start collecting data. And that's that. Train's good to go. So on the more technical side of it, so RILA, as probably I was expecting to get lots of questions later about what it actually means, is Rail Infrastructure Alignment Acquisition. This pretty much says that we're going to pick up everything that by GPS. Inside the actual units, then there are IMUs, which then sort of accounts for sort of velocity and changes in direction. And then also laser vision technologies, all in lightweight cab fiber units. Normal operating conditions, it connects to a coupler like you see in the video, whilst the train is pastures are moved at line speed. So this is sort of really efficient that we don't have to get any possessions. We don't have to have any line speed reductions. We can run everything as is in normal services. So yeah, about 2 minutes to connect the RILA track onto the train. Usually there is a bit more dwell time just in case there are issues with certain couplers, but yeah, primarily for 2 minutes. And then this is how we sort of do everything. Then is by pretty much they do 4 runs on each line, which then allows us to sort of merge the point clouds together to bring the accuracy right down. As you can see there, yeah, the track age and stuff is better than 1 millimeter. It's picked up with a different sensor. And then once both the 3D point clouds are merged together, you're looking at about plus or minus 8 millimeters in X and Y. Bit about the scanner, rotates at 250 hertz, 1 million laser pulses per second. You're looking at there's very dense point clouds coming out of this, and there's a lot of noise, which you see later on. But yeah, by the time you put your GPS, your IMU, everything, point clouds and merged together, you're getting pretty good X and Y absolute accuracy, which then is pushing us down the route of allowing us to do certain things within the survey standard for net equipment. So RILA engaging. So initially, this is the structure we saw earlier. This is what is the point cloud. Pretty much millions of point clouds, millions of points making up a picture. From this, you can't really see much. It looks a bit noisy, very dense point cloud. The way I sort of look at it, then I sort of start looking at changing the sort of colors of things or reducing the density. And as you can see there, you can pretty much see the stones in detail on the masonry sort of arch. Now we have different views, then you can actually see the stones and keystones, all parts of it. You can use the RILA for inspections to a certain extent. As you can see there, you can actually see stones protruding, the keystones at the top. And then pretty much the output from that, once we've done a slice and got our X and Y coordinates, so then there's very much more detail than what we've had previously. This gives us every single nook and cranny of the structure and gives us all the accuracy we need. So in comparison, got pull and tape, the laser suite, structure gauging train, and then we have RILA. So you can see the comparison there that we sort of taking the squareness out of the structure. We're actually picking up what's there. We covered the whole completeness of the structure. So if there was any bits like in pull and tape, we may miss a wall hanger, a protruding stone, anything. We know in RILA we captured the whole lot for your points that are so close or so dense. So a bit on vehicle and vehicle dynamics. So in Wales, we currently have 65 vehicles permitted to run on Wales route. That's everything that's in the sector appendix at the moment. Going forward, so I don't many of you are aware of what's going on in Wales at the minute. We've got a massive vehicle introduction programme. We currently got classes 7, 6, 9, which are going to be the new Cardiff, Rumney to Penarth trains. The 170s, which now run currently up to Ebervale and up to Maesteg. The 230s, which are the old underground D trains, are now running Wrexham to Bidston and doing Chester to Wrexham 2. The Mark 4 coaches, which are going to replace the Mark 3 coaches on the Gerald line, so that's the Holyhead to Cardiff. We've got the new CAF Class 197, which is going to be the go everywhere in Wales train pretty much. The 756 and 231 are the new vehicles by Stadler, which are going to be running predominantly on the Cove Valley lines, but interfacing the Cardiff Central. Because of electrification through the tunnel, it now allows us to run the 387s, which currently run on Western Route, but they're now going to be running to Cardiff also. The Class 800, which we're all aware about, the IEP, which runs into Cardiff and down to Swansea and even sometimes down to Pembroke. But we've also got them now for West Coast Avant. You can be looking to run them on the North Wales coast. The W10 and W12 is a new project which has started fairly recently, which we're looking at running W10 and 12 into Wentloog at Cardiff, at Newport. So lots of work's going on the place to introduce even more vehicles. So by the time we've actually introduced them, we could be looking more like 75 vehicles committed running Wales route. So track geometry features that will affect the vehicle dynamics for gauging. So you're looking at horizontal radiuses. So this is going to give us both our end throw and center throw. Potentially as well, we can have end throw and center throw towards adjacent structures or adjacent tracks. Vertical radius, which gives us a change in height, and it's usually dependent on suspension modes as well. We've got the cant then, where your train could be sitting depending on line speeds. So that could put us toward the inside or outside of a curve. The track quality, which when we're doing clearance calculations is usually defaulted to poor. But if we could like genuinely actually understand what the track quality is, and with to manage track position, maybe managing how our track quality is measured, then potentially we could be looking at good track quality to reduce the tolerances. Track fixity is then usually used depending on your ballast types, or your subgrades could be possibly, but this is mainly ballasted track, slab track, longitudinal timbers. All depends how much movement you're going to get on your track. Sideware, so heavily side-worn areas may have a lot more lateral movement than brand new rails. S&C positioning, especially near platforms or tight structures, because we have taken into account the much tighter radius of the switch. This does give us very big end throats. And moving on to line speed, so that this then was obviously going to give us an issue when we're looking into sort of our clearance runs. If we go high line speeds, we're looking at big movements towards the outside of a curve, so that could be a sway of your train. And at the same time, if we've got highly canted curves with really low line speeds, we could be looking at sitting on the inside of curve and cause us some issues there. In some instances, I know up on West Coast North, they look at the line, the actual wind speed could be an issue with your sort of sway calculations. Now, all these sort of elements then make up our kinematic envelope. Other things that could affect it. So this is more on the vehicles and the vehicle builders then. So presence of secondary suspension. So this is your airbag suspension, which just takes out the sort of bumpiness of a ride wheel. Your suspension modes, which there's 4 types we usually use, which would be your crushed mode, tear, and at the same time it could be inflated or deflated suspension mode. This way, again, based on suspension and based on train movements. Your vehicle lengths and dimensions, your widths and your distances above bogies and bogie centre to bogie centre will also affect your end throw and centre throw calculations, which feeds into nose overhangs. And the same again as the side wear. If you've got plenty of flange wear, then your train's got lateral movement, and all these sort of tolerances have to be taken into account. That's just a nice picture of a very, very tight structure. So for clearance calculation, this is the standard Netrograde sort of suite we use clearout as our sort of base. As you can see there, we've got our kinematic envelope, which is the blue line, the train shape one, which is made up of everything we discussed in the previous slide, which then gives us our maximum outline of that train going at both line speed and trundle speed, as we call it. The actual red line you see there is the structure survey with the applied equipment tolerance. So this is the actual RILA data being put through the clearance software. And as you see from that red box there, that's giving us our shortest distance between our KE and our infrastructure. So we take over these sort of areas. We have our 0 to 1100 mil, which then covers our lower sector. And then we have 11,000 to 2 meters, which is middle of the train. 2 meters to 3 meters then covers a window box area, where with the Mark 3s, especially with the drop light windows, that's where we're going to be looking at issues with tighter structures where people could potentially put limbs out the window. So we make additional sort of tolerances and clearances then to sort of allow for this. And then as you're looking towards the top of the train, 3 meters to 3.5 meters, we have our cant rail, and then anything above. And we classify these clearances in these areas because there's a slight change in how we maintain the risk for these sort of areas. When things go wrong. So as you can see there, it's more likely a container on the back of a freight vehicle, which is sort of took a corner, well, inserted a corner into a masonry arch. As you've probably seen, the newsletter went out, there was stepping distances, so I haven't really gone much into stepping distances, but we always look at making big improvements to clearances. But at the same time, we need to trade off at platforms instead of just moving everything away from the structure, but actually taking into account that there's going to be a massive gap left behind. So we're trading off where the risk is risk of collision or risk of passenger safety. So it gets quite difficult when we have platform failure to face. Also have damage to vehicles. So that could happen at any point, depends on what's running. This looking more like a Steam logo, maybe. Yeah, we don't really maintain for that sort of sizes, so potentially there's issues out there which we don't 100% know about yet, but they may come up. And the same again, platforms always want us designed tight. So we need to be as tight as we can, but at the same time, not too tight. And this is where we have issues where Cobra's been taken off platforms and the like. So RILA, we've just talked about using the gauging data so far, but what we actually got from RILA is this is what we procured from them. So that's the structure we saw earlier. This is the sort of video footage we get from the RILA kit. What we've had is a frame every 1 meter of the track. So in Wales now we have pretty much a video library of the whole of Wales by track, by ELR. Every meter we have a picture. We also have, those of you in the know, this is an SEX file, so it's all our 6 foot data. So we didn't really maintain any type of database for 6 foot data previously. Now we have a full database for the whole of Wales, which is a system we've never held and we wouldn't be able to maintain if we didn't have RILA. And previously, as you see in the bridge, that's the point cloud footage, all within the track rail strings. Now, them white lines, the track rail strings, we have them for the whole of Wales as well. So at the moment, we currently have a map of Wales by rail, by each sort of setting, by each cant, each radius, everything we can pick up from it instantaneously. As well as that, we got our gauging files, we got topographic data, 6 foot survey reports. And then in some areas now we're looking at between Swansea, Cardiff and Newport, we can have a full feature extracted topographical survey. So a couple of ideas going forward. We're looking at substituting traditional topo surveys with RILA data. So this is a feature extracted topo which RILA provided, which we do anyway using the conventional survey, but this has been based on not having to set anyone out on site. We do have issues with tying in with snake grids at the minute, which we're working on, but in general, we've based other designs off this data and it's been spot on. Bit more complex, probably not something we'd probably be looking just doing without any validation, but potentially it gives us a good map of the area and we can see what's there. It takes us through the rails, OLE stanchions, even gives us a topographical survey of surrounding land. It pretty much gives us everything we need to do early grip stage design or feasibility. On top of that, we're also starting doing tamping trials. So the thing we're looking at doing now with the guys in Fugo is, could we provide the maintenance guys a front offset file without actually going to site or with minimum validation? So this is pretty much the guys that are requesting topo from an area, doing a design, doing some validation with the trolley, and pretty much tamping to design every time. Which on Western so far has gone quite well on the first site they done down at Hallavington last week. Next part we're looking at is automated feature extraction. So we currently, as you saw earlier, get point cloud, which is lots of noise. There's now a project running which is automatically recognizing features and extracting them into a wireframe model. From this, we're looking at linear referencing. So updating our LIPS asset databases to make sure everything's back aligned where it should be. The one issue we have always had is miles, yards, and chains. Is this the start of the end? Maybe, I don't know, but it's something we can do. We can start looking at making changes to allow us to have accurate meterages. But we can take cross section of anywhere in the railway, anywhere where the laser can see from the 4 foot. We should be able to make some type of cross section of it. As with this, picking up height staggers, your tracks, and then at the same time picking up your OLE stanchions or any other significant structures along the way. There is a project on Western running where they're picking up all smaller assets as well, so AWS, TPWS, lots of other bits and pieces which they can automatically find in the point cloud data. From this, then it can automatically produce a report which could be correlated with ellipse in the future. We're moving a bit further forward, looking at digital twin models. This is taking the wireframe, first off taking the point cloud, changing it to wireframe, and then adding render. These could be used for anything from IDCs and IDRs, introducing new track, new components, new assets to the railway infrastructure, and pretty much running the tests. You could run a train through and see if there's any clash detection. As well as that, this is pretty good for presentation of new stations or any large renewals. And then going forward, you can even use this for 4D BIM. So that's putting more of your project sort of life cycle towards it as well. Our next thing we're looking at currently is using a two alignment design. We're currently looking at this between Cardiff and Pilning, and it's all about maintaining our sort of track and the wires. We're trying to keep the right sort of heights of staggers in place at the same time, trying to set the right sort of track quality in place as well. So by using the RILA rail strings as a baseline survey, we're applying the two alignment design for Pilning to Cardiff, allowing us to build a design model with all interfaces tied into one survey grid. So this uses a snake grid between Cardiff and Pilning. Hopefully we can quickly and easily baseline linear referencing, so we can have a master chainage out to Pilning, which then everything will have a master chainage from that point to an asset, so we always know where everything is. As well as everything being in X, Y, and Z format as a pointing space, we will also have a meterage. We will manage the track positions through tamping or renewals to a single design. So this is going to stop us having many isolated designs and many isolated surveys, and instead having one massive survey and one massive design, which is significantly going to reduce the cost. And as we go through the next few control periods, we implementing this by renewal, by tamping, just as part of our general work bank. We'll be able to monitor the actual deterioration through rebaselining in RILA. So we've never had trend analysis in that way before. But when we've had our sort of decision support tools working out our deterioration rates, this has been based on our NMT data and picking up track fault locations instead of actually finding a difference, a delta between the data. Because we know where our track is, then we'll be able to tighten up our tolerances, especially on the gauging track positions. But there may be other areas we may be able to use the known track position to reduce our inspection frequencies. And this is pretty much how it's going to work. We had the RILA initial survey. We then provide the TAD string, which is our design string. And there we are. If this is in a vertical plane, we're looking at that's how lift's required to get to it. When we do another survey, perhaps the track's, well, hopefully the track's gone down and not up. Again, we'll be able to see how much it's deteriorated from the data. And same again, how well many is going to go. But we can set limits then, so we know when the track needs to be lifted by, when it's outside of tolerance. So this will always give us an idea of how far away track is from design. And then this is just something that Fugo provided a while back, but it gives you a good idea of what we can and can't see in the point cloud. The thing is, you can see pretty much everything. And if you were to stop at any point, you can measure anywhere in this and it'll be accurate within plus or minus 8 mil. But yeah, this is the colorized point cloud. So this has got like a video background to it, but majority of this is points. So you could measure anything, and the level of detail is immense. Going through the S&C, there's potential in the future possibly to look at sort of the detail in there and get S&C measured. You can look at distances between things, quick measurements. You wouldn't have to send maintenance out there to measure the distance between track and mushroom for a axle counter section. You could do it all via this sort of system. You could do your sighting distances. So looking at vegetation control, you can pretty much stop in one place and look in each direction, see if your vegetation is restricting your views, especially at level crossings or user road crossings. And then the same as if you're planning the site and you want to go to the sea, where you're going to put your lookouts before getting there, which I suppose isn't very much use now in Wales. Seems to be going away from lookouts, but potentially you could do all your planning from this as well. And again, you can stop anywhere you want. You can zoom in, zoom out, take a view from above. You don't have to be a rail height. You can do your signal sighting from it. It could be all sorts. But yeah, that's what we're looking at now, is potentially going further now in the future and seeing what we can do. So potentially in the future, we got those sighting distances, level crossing distances, general measurements, early grip stage development, asset identification, something else that people are now providing are ballast profiles. So this allows us to plan for sort of onset of warm weather, to know where we're going to have a ballast ballast issues, where we have plenty of ballast, we can lift it across to somewhere we haven't. And the same when we sort of looking with the structures team about ballast depths. So we're using the RILA point cloud data, we can actually pick up an underbridge and pick up the rails and know exactly what the depth of the ballast may be based on previous design drawings. So yeah, in summary then, we're looking at the gauging survey techniques and improvements in accuracy and repeatability. So that's the good thing we found about RILA, is that we can repeat this every time to near enough the exact same point of structure based on GPS and meterages and certain datums. Efficiency and benefits in safety, cost and program. So we're not looking to put anyone up on the site as much anymore. The cost then, because we're doing things in a larger scale rather than isolated locations, we can get the cost down. And the program, so we look like I said earlier, 6 weeks versus 3 years is a massive improvement. Talk about RILA, gauging using RILA plus the increase in accuracies, improvements to gauging data. So since we've run this now, we've got a massive improvement now with sort of gauging database. We've had more informed decision making since having this data by doing quick checks. Quick insight into vehicle dynamics and what makes up the kinematic envelope, and then how all this is applied to clearance calculations. A little bit on when things go wrong. Luckily enough, we haven't really had much to worry about in Wales over the last couple of years. And then, yeah, what we're looking to do in the future with 3D coordinate data and how it's benefiting us so far and what we're going to benefit from in the future. And that's pretty much it. If anyone's got any questions.
All right. Thank you, Craig. I hope you can hear me now.
Yeah.
Can you hear me? Right. Okay. So if anybody's got any questions, can I suggest we type them into the chat box? I'm sorry, I should have said this at the beginning. We'll take some questions then from anybody. So if anybody's got any questions, just type your question into the chat box, and I will read them out. Okay. So, have we got any questions? Right. Well, I'll start off a question if we haven't got anything else come in yet. Then, Craig.
Okay.
So, I mean, that's absolutely fascinating presentation. So, can I just ask, how much does it cost us to collect this data? You were talking about, it's clearly a very cost-effective means of collecting information over big distances quickly, with potentially multiple uses for it. So, can you tell us how much the exercise for Wales cost?
So to capture everything in Wales over a 6-week period, it cost us just short of £3 million. But we haven't really realised all the efficiencies and benefits yet. But the last sort of call, when we sort of look through, and we're using it to about 5% at the minute, we're looking at somewhere near £2 million efficiency so far.
Right. So but when you start thinking in terms of, your suggestion that it was going to be 3 years to sort of done that by conventional means, working flat out, then £3 million isn't a huge sum of money at all, is it? But we've got another question come in. Can I ask you put your name on the question when you actually ask them? But we've got a question now. What is the difference between this and the measurement train? Is there anything this can do that the train can't, or vice versa? Could RILA replace the train? So this is the new measurement train I think we're talking about.
Yeah, so the thing with the new measurement train is everything's done off cords and sensors, so nothing is actually geospatial. I know they use GPS now for longitudinal position, but nothing is actually point in space accurate. Two different kits for two different things, really. I looked at if we could run a mathematical or theoretical NMT over this data. But I think at the minute, the sort of data processing time from Fugo is a bit slower than what you get from the NMT due to the volume of data that each of them collect. So yeah, it's two completely different bits of kit really for two different completely applications, but potentially in the future, who knows?
Okay, thank you, Craig. Right, we've got another question come in from Darren. Craig, due to the cost, when will this exercise be done again or need to be done?
I was having a chat with someone from Fugo this morning actually, and yeah, so we were looking at pretty much re-baseline our survey every 3, maybe 4 years, but potentially there could be aspects of it we may be able to do a lot more frequent. But yeah, I think based on the money at the minute, because we haven't realised every single bit of efficiency, we're still trying to prove that it's the right way to go. But maybe in the future we could be looking at this a lot more frequent than what we're doing now, because this is our first stab, and as a region now we're doing Wales and Western. Perhaps as a region we may come together and have a bit more of a frequent framework with Google.
Yeah, clearly the more data we can collect in a single exercise, the more cost effective it becomes, isn't it? Right, have we got any more questions? Any more questions?
Andy, there's a question that's come through. I think James has posted it through to the PWI.
Right.
From James Eustace. It says,
right.
What was the accuracy of this survey, band 1? Sorry, I may have missed this. And how can it be linked to topographic surveying for track renewals?
So we've done 4 runs. We're looking at band 1A accuracy, which currently we are going through to around grip 4, Form A design. There are sort of bits and pieces we have been looking to make sure this data could be more accurate than what it actually is. But yeah, we're using it now for vehicle introduction program to pretty much do all our Form A's against. We've used it for a few maintenance schemes now to do actual tamping designs off. But yeah, there's certain levels of validation and verification we still have to do in certain areas. But yeah, band 1A accuracy, that's what we're looking at in the 3100 standards.
Okay, thank you.
And James goes on to ask, how does all this link into the BIM collection of information?
So currently we're holding this data on project-wise, and it's been fed into the BIM team. And yeah, we are looking at areas where we're doing large renewals or large, like we said, through alignment designs. All this will be done through BIM and by producing BIM execution plans and understanding how we'll all get used in the future. And to be honest, a lot of it is the integration side of things. So we make sure we've got the snake grids in the right places and make sure everything's integrated.
Okay, thanks, Craig. Right, any more questions? Sorry.
Can you see the question from Louise Wally that's just come through, Andy?
Okay. But nothing's come through here.
He says to tighten up the tolerances using TAD, I believe TAD, and manage track positions, would that involve increasing the track's fixity or the gauging engineer accepting a lower clearance?
So potentially, if we know where the track is, currently we apply a 25 mil tolerance to low track fixity. But if we know where the track is and we're performing enough frequent then surveys, then potentially we could look at adjusting our track fixity down to medium track fixity, which then will give us an extra 15 mil on clearances potentially. But I think that's something we're going to have to manage locally per region, or one way of proving the track fixity.
All right, thank you, Craig. Right, okay, is there any more questions?
There's a question from Holst. Craig mentioned towards the end of the presentation depth of ballast on structures. Can we tie into this data from a local survey? For example, taking a level from the underside of the underbridge, then knowing the bridge construction could calculate ballast depth? That's from Emma Holst.
Potentially, the part of the structure we need to know about is the part we can see. And being a train-based survey, we can't see undersides. So what I've been picking up with the structures teams is pretty much looking at the top of parapets, top of girders and stuff like that. As long as we know from a design drawing where the top of that structure is and the distance between there and the bottom to the deck, then, because we've already picked the rails up, we know the delta then between the bottom of the deck and the rails. So by the time we take up construction depth of track, we can potentially have a fairly accurate stab at the actual ballast depths under the track. All based on structures having the design drawings and knowing the distances between top of parapets and bridge decks.
Okay, thank you, Craig. Right, any more questions?
There's a question from Stuart. Have you had any challenges with data quantity and extraction when using RILA data?
So data quantity, I think for Wales it came out just short of 6 terabytes of data, which for the first 12 months I was managing by myself pretty much. Now we're starting in a project wise, it's a bit easier to filter through it. The files are fairly small, there's just lots of them. So trying to find what you want is can be quite difficult, but it's quite manageable then. The only issue we have had with sort of using the data, which has been so much detail, has been using our design software. Bentley Railtrack hasn't liked the amount of data we've been putting into it. So in some places, like especially the point cloud, because I have a fairly limited machine with a minute laptop, I'm looking at using probably somewhere between 5 and 10% density in the point cloud. So there is a lot of data, and I think just as Network Rail or whoever going forward, we're going to be looking at the storage and also how we manipulate the data and the software we use. But a lot of this is going through project-wise and going through the sort of the BIM teams we have regionally now to sort of look at that sort of software requirement.
Right. Any other questions?
My apologies if this one's already been asked, but Steve Clark says, what is the difference between this and the measurement train? Is there anything that this can do that the train can't, or vice versa? Could RILA replace the train?
I'm done already. Yes, so pretty much the NMT will pick up isolated faults and the GPS location, when RILA will pick up everything, and you could determine certain faults from the data. But yeah, I think the data processing times may not make that viable to get rid of the NMT just quite yet.
Right. Thank you very much, Craig. Right, we've got another question come in from Andrew Wilson. Yeah. So RILA data is to 3mm accuracy. Has the rolling stock engineer improved the accuracy of kinematic envelopes to the same extent?
No, the thing is with the rolling stock stuff, it's all done as per the manufacturer of the rolling stock. Some of the KEs are very old at the minute, and yeah, it's up to the actual manufacturers themselves to do that. There's a project running in the background by the guys in technical authority to look at rescanning them in some type of point cloud shape or form to get a newer profile for a lot of our vehicles out there and get a bit more sophisticated, a bit more accurate then. But in terms of RILA, it's purely been just purely for our track benefit at the moment.
Right. Thank you. I can recall when the 153s were introduced, we found that there was quite a lot of variation in they modified the steps, and there was quite a lot of variation in actually how big the trains were. All right, thank you for that. Right, so if there's no more questions, any more questions? No. Right, well, in that case, I would like to thank Craig very much indeed for making the presentation tonight. I found it absolutely fascinating, and it never fails to amaze me how quickly this kind of technology has been moving on. When I very first started on the railway, my first job was working in the gauging section of the then southern region. And I must admit, we were very into poles and tapes and spirit levels and string lines and things like that for actually measuring up outer gauge loads. It's quite ironic that we've now got this wonderful system for doing it, and yet we don't actually move many outer gauge loads anymore. But such is life. So can I thank everyone for supporting us tonight, and thank Craig for his presentation. So
thank you, Andy.
Right. Okay.
If I may just interject,